First, distribute 2 to the negative 3, u to the negative 3. They're both negative. So they're going to go to the bottom and become 2 to the positive 3, u to the positive 3. And then a 1 on top because there's nothing left up there. And then 2 to the third is 8. Done. Okay, number 12. I have 3 on the top, and then this guy is going to come upstairs and be b to the positive 2. Then I have 3a on the bottom. This guy is going to become a to the positive 1 on the bottom. This guy is going to become a b to the positive 2 on the bottom. Okay, now there are 2 things that cancel. Can you guys see anything that cancels? Yes. Yep, 3's and b squareds. So there's a 1 on top because nothing is left. What do I do with this? There's one a here and another a here, so that's perfect. All right. Number 13, scientific notation. Okay, so this is a division problem. So you divide the numbers in the front. Divide the numbers in the front, then put times 10, and then subtract the exponents. You have to be really careful here. It's not 6 minus 3, it's 6 minus negative 3. Okay, what is 7.1 divided by 2.7? Anybody tell me? The reason I don't know is because my calculator is on the charger. No one knows. 2.629. So 2.63 times 10 to the 9, positive 9. 6 minus negative 3 is 9. Oh, it's already balanced. Look at that. It's like the first time that's ever actually happened. Do you guys know what I mean by that? The number in front is between 1 and 9.9 repeating, so I don't have to do anything to it. That's awesome. Okay, that's it for warm-ups. How exciting. Okay, now if you guys could find the page in the packet that has a big graph on it and it says the big race number 52. And on this graph, I'm going to use colored pencils and a ruler, a full ruler, not a protractor straight edge, a full ruler. So I put colored pencils in the middle You might want to grab a ruler. Okay, so I want to remind you before we start about what we did on number 35. You don't need to get your notebook out. Just look up here real quick. So we're going to be graphing lines today and the equations and stating the equations. And the equation is y equals mx plus b, where m is the slope and b is the y-intercept. And remember, the slope is rise over run, and the y-intercept is the start, or where it's on the y-axis. So just keep that in mind as we are doing these problems. So it's called the big race, and it's actually a tricycle race. And we're going to graph each person and find their equation. And it's going to be great. Before a big race, participants often compete in heats, which are preliminary races that determine who competes in the final race. Later in this chapter, your class will compete in a tricycle race, not a real one, against the winners of these preliminary heats. In the first heat, Leslie, Kristen, and Evie rode tricycles toward the finish line. Leslie began at the starting line and rode at a constant rate of 2 meters every second. Okay, so we're going to start with Leslie. She began at the starting line, which means that her distance from the starting line was 0. I'm just going to take a pen for now and make a dot at 0. Her distance from the starting line was 0. And then she went 2 meters every second. 2 meters every second. Copy that pattern, 2 meters every second, all the way up to the top of the graph. 2 meters, 1 second. Okay, and then I'm going to take my colored pencil. As soon as I get all my dots in place. Go all the way to the top. And then at the top, right, Leslie. And then we're going to state her equation. So y equals 2 meters per second, x plus 0, because she was started at the starting line. So you guys gonna see what we're gonna do with this. We're gonna graph all the riders, figure out their equations. Okay, now I'm gonna switch to a different color. Okay, now we're on Kristen. Kristen got an 8-meter head start and rode 2 meters every 5 seconds. Okay, so start with her 8-meter head start. So Kristen got an 8-meter head start and rode 2 meters every 5 seconds. 2 meters every 5 seconds. Man, she's slow. Sorry, Kristen. 2 meters, 5 seconds. 2 meters, 5 seconds. Okay, what is Kristen's equation? Y equals so almost, okay, hold on. So 2 meters every 5 seconds, x plus 8. Perfect. All right, now grab a third color. Evie rode 5 meters every 4 seconds and got a 6-meter head start. Okay, 6-meter head start. 5 meters every 4 seconds. Green. Oh no. Too much stuff. Sorry. Okay, what was her name? Evie? Okay, what was her equation? Y equals 5 meters every 4 seconds, x plus 6-meter head start. You okay? Okay. B, after how many seconds did Leslie catch up to Evie? How far were they from the starting line when Leslie caught up to Evie? Confirm your answer algebraically and explain how to use your graph to justify your answer. Okay, so we're looking for when Leslie caught up to Evie. Okay, so here's Leslie. She's the orange one. She's in last place. She's in last place. She's in last place. Okay, right here she passes Kristen. Does that make sense? Okay, now she's in second place. And right here is where she passes Evie. Okay, so what we're going to do is name the coordinate. This coordinate is what? 816. Okay, so what does that mean in a sentence? I'll start it for you. After 8 seconds, Leslie passed Evie at how many meters? 16 meters. C, the winner of this heat will race in the final big race. If the race is 20 meters long, who won? Use both the graph and the equations to justify your answer. Okay, so what I want to do is I want to go to 20 meters on the y-axis, and I want to draw the finish line. Okay, so take your ruler at 20 meters, and however you want to, I'm going to do mine in red because it's finish line. Okay, so who won? Who crossed the finish line first? Leslie. Okay, and why does that make sense from her equation? So take a look at this number and this number and this number. What's faster? 2 meters every second, 5 meters every 4 seconds, or 2 meters every 5 seconds? 2x, right. So this is the steepest because it's the biggest slope. Okay, how long did it take her to win? Yep, so she won in 10 seconds. How long did it take Evie to win? And just do an estimate. About what? 11 point something? I was gonna say it's probably 11.25, knowing. But now we have Kristen over here. We really can't tell from the graph. Okay, so what we're going to do is we're going to do it algebraically, which is what the book was talking about. We want to know when she hits 20. So we're going to put 20 in for y because this is the y-axis at 20. So this is going to turn into a function machine. Okay, what do I do first? Take away 8, beautiful. Okay, now there's a lot of ways you could do this. I like to multiply both sides by 5 right here. And cancel out the 5s on this side because one is in the top and one's in the bottom. I got 30 seconds. Does that seem reasonable from our graph? If we went up 2 over 5 and up 2 over 5 again? I think it looks pretty good. Poor thing. Okay, last thing. The school newspaper wants to report Kristen's speed. How fast was Kristen riding? Write your answer as a unit rate. That is a rate with a denominator of 1. Okay, what they mean is take the rate, which is 2 over 5, and do 2 divided by 5 on the calculator. What is 2 divided by 5? 0.4. So 0.4 meters per second. Okay, once you're set with that, flip the page over to the second one. So that's number 52. 52 is all done. Is yours pretty? Beautiful. I like colorful graphs. They make me happy. All right, let's see what kind of situation we have here. Heat 2. In the second heat, Elizabeth, Kay, and Hannah raced down the track. They knew the winner would compete against the other heat winners in the final race. When the line representing K's race is graphed, the equation is f of x equals 2/3 x plus 1. What was her speed in meters per second? Did she get a head start? Okay, so first of all, did she get a head start? Yes. And what was her speed? Do you guys know what 2 divided by 3 is? It's like 0.67, so 0.67 meters per second. Did you guys know that was 2 divided by 3? Anybody know that was 2 divided by 3? You didn't know, did you? Okay, so, oh, I see. Oh, I see why it's funny. Okay, so we're going to start with her head start of 1, and then we're going to go up 2 over 3. And use it, you can use the same colors, whatever. So this is K. She got a head start of 1. And then up 2 over 3. Man, I can't believe I haven't used pink yet on Pink Day. Missing an opportunity here. So should I be freaked out by the fact that they put f of x? What is f of x the same as? Y. Okay, so if you hate that, you can switch it to y. It's just the same thing. Don't be freaked out. Is everybody good on where the one went and where the 2/3 went in the graph? Okay. So this is on your quiz on Wednesday. Basically taking something like this, starting at 1, going up 2/3, drawing a line. That's pretty much what it is. Okay, next. Elizabeth's race is given by the equation f of x equals 12/16x plus 4. Who is riding faster, Elizabeth or Kay? How do you know? Okay, so we're going to do start at 4. So head start of 4. And then up 12/16. Mm-hmm. It was Elizabeth, right? I forgot already. Yeah. Up 12/16, which makes it go to the point 16/16. Okay, so here's my question. What does 12/16 reduce to? Mm-hmm. Okay, so what's faster, 3/4 or 2/3? 3/4. But just by a little bit. Just as she started paddling, Hannah's shoelace came untied. Oh no! Being careful not to get her shoelace tangled in the pedal, she rode slowly. Hannah's race is represented in the table below. At what unit rate was she riding? Okay, so let's see. We can't really do the other points. Everybody graph the point 1410 first. Okay, so I got the point 1410, and then I wrote down the first 2 points from the table down in the white space. Do you guys remember how to find the slope from 2 points? X1, Y1, X2, Y2. Slope equals Y2 minus Y1 over X2 minus X1. Okay, so now we can count the boxes, and we're going to go forwards and backwards to figure out our equations. So you have the point 1410 up to over 7. And then backtrack down to back 7. Down to back 7. Okay, so Hannah's equation is f of x equals 2 over 7x, and then what was her head start? 6. Okay, last thing. To entertain the crowd, a clown rode a tricycle in the race. His race can be modeled by the function f of x equals 20 minus x. Without graphing or making a table, we're going to actually graph it. Fully describe the clown's ride. Okay, so down at the bottom, right, f of x equals 20 minus x, which will be the clown. And this one's going to require us to do some critical thinking. Critical thinking, no. How could you, Mrs. Salmon? On Monday? Okay, really advanced question. What is this clown's head start? 20. Okay, these are backwards. So if you want to, you can switch those and make it negative x plus 20, which is what I would do. So he has a 20-meter head start. Assuming he's a guy, I don't know. Okay, and then what does a negative, this is a -1 slope. What does that look like as far as graphing? So remember, any number over 1 is itself, and you're going to go down 1 over 1 each time. Down 1 over 1. Okay, so he's there. I'm not a big fan of clowns. When I was a little kid, my parents went to Las Vegas and they brought back this giant stuffed animal clown for me from Circus Circus, and I was really scared of it. Anyway. My sister got a cool coin-operated slot machine, but no, I had to get a clown. Okay, so here's the question. Can anybody tell us what the clown did? What did he do? What was his drive? True. His drive was a tricycle. What's happening here? Yeah. Yeah. So he started at the finish line and rode backwards toward the starting line, which is kind of hilarious. So this is the finish line at 20, and he rode backwards toward the starting line. Good stuff. Okay, we're done with that. All right, so now can you guys read this, please, and thank you. Do you guys all know what I mean by finding slope from a graph and 2 points? So from a graph, you draw in the triangle and do rise over run. From 2 points, you do y2 minus y1 over x2 minus x1. I'll write that on the board, by the way, during the quiz, so you don't have to memorize that. Do you know what I mean by scientific notation problems? Okay, and then graphing lines is what we're just working on right now. So if you could take your packet, please, and flip the page over to the homework. This is tonight's homework, which I'm going to give you the rest of the period to work on. But I want to go to the back, and I want to do one with you so you can see what I'm asking for here. So these are kind of like what we just did with the big race. So let's do number 13 together just so we're all really clear on what to do. So this says a 2-meter head start. 2 is the y-intercept. So go up 2. And then the slope is up 5 over 4. 1, 2, 3, 4, 5. If it's off the graph, you can estimate it. But what I really want you to do is to be able to develop the skill of backtracking. So up 5 over 4 would be the same thing as down 5, back 4. It's kind of line up. Pen is dying. That's sad. Okay, do you guys understand what to do for the back page there? Do you have any questions on the front page, like what to do for any of the things? So on these four in the middle, you don't need to find the whole equation. You just find the slope, which is just make the triangle rise over run. On these, just be really careful with the ones that are going downhill are negative. Okay, you guys go ahead and work on this. Please and thank you. Come see me. I will put the answers up at the start of the period tomorrow so we can go over any of them that you need.